to explain about chemical changes. Hi students! In our last class, we have learned about the physical changes. Now, let us know about chemical changes. OST. Chemical change. Definition. A change in which one or more new substances are formed is called a chemical change. A chemical change is also called a chemical reaction. Rusting of iron. Rusting of iron is quite a familiar chemical change for all of you. It acquires a film of brownish substance. This substance is called rust, and the process is called rusting. Iron gates of parks or farmlands. Iron benches kept in lawns and gardens. Almost every article of iron kept in the open gets rusted. At home, you must have seen iron shovels and spades getting rusted when exposed to the atmosphere for some time. In the kitchen, a wet iron pan or a tawa often gets rusted if left in that state for some time. Rust is not iron. It is a different chemical form of iron which gets deposited. Activity 1. Take a small piece of a thin strip or ribbon of magnesium. Clean its tip with sandpaper and introduce the tip into a candle flame. It burns with a brilliant white light. When it is completely burnt, it leaves powdery ash. Does the ash look like the magnesium ribbon? No, it looks like a grayish-white powder. The change can be represented by the following equation. Magnesium plus oxygen gives rise to magnesium oxide. Caution! It is dangerous to stare continuously at the flashlight emerged during the burning of magnesium strip. Collect the ash and mix it with a small amount of water. Stir the mixture of aqueous solution well. Now, test the aqueous solution with blue and red litmus papers. What did you observe? Yes, the mixture turns the red litmus paper to blue color. This indicates that the solution is basic in nature. On dissolving the ash in water, it forms a new substance, that is, magnesium hydroxide. This change can be written in the form of the following equation. Activity 2. Take a beaker or glass tumbler and dissolve about a teaspoon of copper sulfate into half a cup of water. Copper sulfate is commonly called as blue vitriol. Add a few drops of dilute sulfuric acid to the solution. After some time, you will get a blue-colored solution. Save a small sample of the solution in a test tube or a small glass bottle. Drop a nail or a used shaving blade into the remaining solution. Wait for about half an hour and observe the color of the solution. Compare it with the color of the sample solution saved separately. Do you see any change in the color of the solution? Take out the nail or the blade. Has it changed in any way? The blue-colored solution has changed into a green color solution. The color change of solution is due to a chemical reaction between copper sulfate and iron. The green-colored solution formed is iron sulfate. The brown-colored solid deposit on the iron nail is copper. The chemical reaction taken place is Activity 3. Take about a teaspoon full of vinegar in a test tube and add a pinch of baking soda to it. You can observe a brisk effervescence and also hear a hissing sound and see bubbles of gas coming out of the test tube. Allow this gas to pass through freshly prepared lime water. When the gas is passed through lime water, calcium carbonate is formed, which makes lime water milky. The turning of lime water into milky is a standard test of carbon dioxide. This indicates that the gas evolved is carbon dioxide. The reactions taking place in this activity are 1. Vinegar plus baking soda gives rise to carbon dioxide plus other substances. 2. Carbon dioxide plus lime water gives rise to calcium carbonate plus water. Summary. In these activities, at each chemical change, one or more new substances were formed. In Activity 1, the ash was the new substance formed when magnesium was burnt in air. In Activity 2, the reaction of copper sulfate with iron produced iron sulfate and copper. Copper was deposited on the shaving blade of iron. In Activity 3, vinegar and baking soda together produced carbon dioxide, which turned lime water milky.